There has been a revolution in archery. Now, this is a bow you may have used in high school, or shooting an apple off of somebody's head at a family picnic, or in more traditional hunting. But you're not going to believe what they've done to these things. Hit the target.
Like any 1,000-year-old technology, the bow and arrow is both simple and ingenious. The harder you pull the string, the more power you get when you shoot an arrow. Unfortunately, since that string is so tough to draw back, it's hard to tap a bow's full potential. Hunters in particular wanted more power. Enter the compound bow.
The compound bow, here at Bowtech in Eugene, Oregon. This is where the revolution is going on. They are transforming the sport of bow hunting and target archery with this. Solving 10,000-year-old design challenges. The end result is something that is far more effective, way more powerful and accurate, and a heck of a lot of fun to use.
Compound bows give you 50% more power than traditional bows with a lot less effort. Unlike a regular bow, when you pull back the string, you don't have to hold all that energy yourself. Instead, you transfer it into this cam system, which compounds the bow's overall force. John Hernandez is Bowtech's design guru.
So what's the motor of the bow?
The motor of the bow is your cam system.
The cams take the energy and transfer it to the limbs, making the string much easier to hold. The energy remains in the limbs until the shooter finally releases it.
You know, holding it steady would help.
Oh, yeah.
But before we fire any more arrows, let's build our bow.
The core of the bow is called the riser. That is this shape right here. And it is made of aluminum. That makes it strong and lightweight. No longer are they cutting these risers from yew trees. They're going to cut the riser from these sheets of aluminum. And to do that, they don't use any blowtorches or any dyes. They actually use water.
The raw aluminum is cut with a jet of water mixed with grains of sand. They're shot at Mach 3, over 2,200 miles per hour. That's 3 times the speed of sound. And it's tough enough to cut through a foot of steel. The water jet is far more efficient than using a saw because it cuts more finely and doesn't create as much waste.
We've got some engineering design challenges to overcome before we can actually call it a riser. We've got to reduce the weight. No one wants to kind of carry this around the woods. And we want to make it look good. So we're going to put this up on that tombstone back there. It goes in like this, and it'll come out like this.
Although we can't see it, the tombstones, metal stands that hold the parts, they move through an automated drilling machine that uses as many as 25 different tools to further hone the riser into its proper shape. It also cuts out holes to make each riser as light as possible. Then vibrating machines buff the metal with a super tough plastic, but one that won't damage a soft metal like aluminum.
So here we have a bow and no wood. And they are hardly what Robin Hood and his merry men would have used to rescue Maid Marian from the evil sheriff of Nottingham.
Now for the finish, Bowtech has perfected the art of creating a leafy look on their bows. It's a process called hydrographic image transfer.
Ink is embedded in these large sheets of cornstarch. Now, the cornstarch is unfurled over a bed of water. And what happens is the ink rests on top of the water while the cornstarch sheet dissolves into the water. And you can demonstrate this very simply by actually seeing how that camouflage just sticks right to the surface here on my glove, but eventually on these bows. Now, they could do all of this by hand, but that would involve a lot of time and a lot of stenciling. And, well, Who's got time for that?
After they're dipped, the risers are washed to removing starches from the original bath. Then they're dried, covered with a rubberized coating to protect from weather and scratching, and dried again. Finally, little touches are put on with an airbrush to make sure the camouflage looks artfully imperfect. Coming up, find out how this ultra-tough plastic puts more power into your shot. Here at Bowtech in Eugene, Oregon, we've shaped our compound bow and we've given it a coat of camouflage. Now we have to string it. Bowtech makes 1,500 sets of strings a day. Strings used to be made from linen or hemp, but these more powerful bows require tougher strings, and they're produced from polyethylenes, some of the toughest synthetic materials around.
This is a blend of 67% Dyneema and 33% Vectron. They use this to make other things too, like bulletproof vests and the lines for parachutes. And they use these polyethylenes mainly to prevent something called creep. That is a stretching of the string, an elongation over time. When the string stretches, the alignment of the bow is screwed up and the aim is going to be off. So creep is bad. Nobody likes creep.
A single bowstring is actually a long, continuous piece of polyethylene woven together like rope. It's made of 22 carefully interlaced strands. The result is more flexible than a single piece of material, but strong enough to take the pressure of holding back an arrow. Now it's time to assemble our bows. Cells of up to 7 people put together 800 of these a day. And here's how they do it.
So we're putting in the handle here.
Putting in the grip.
Now, what are our grips made of?
First, we add the wooden grips.
So there you go.
Then the cable rod, which keeps the arrows from hitting the cable.
That's what those are from. Just pound it down. Take our screw gun behind you.
Then we attach the limbs to each end
Do
of the
that right there.
riser.
You hit the pressure gauge. You're good to go. Okay. Now we're going to pop this out.
And finally, the cam system and cables.
Okay.
We are good to go.
Here, John threads the cables through and around the 2 cams.
Okay.
Now we check the draw weight. That's the amount of force needed to pull back the string. Bows have an adjustable draw weight depending on whether you loosen or tighten the limbs. We've got to make sure we're hitting the maximum draw weight for this particular bow.
That's 60 pounds. Okay. Now, bows together, strung up. We've determined the weight. We've determined the draw length. We're ready to shoot this thing.
The speed of the arrow is critical in the sport of bow hunting. The number they want? 300 feet per second. That's a football field in 1 second. Testers fire arrows and then sign off on each bow.
So we're in this, the shooting booth. And we're here to test, really, apply a standard to our bow.
Exactly. This particular model and the performance it's supposed to hit, we got to hit a minimum of 300 foot a second.
To do that, we have to fire through this red chronograph.
Yep.
So it's measuring the velocity of our arrow.
This device is a lot like something you see at a highway speed trap. The radar measurements register the arrow's velocity.
Now I got to put the finger in front of the trigger. I want
just touch her down and squeeze. Yeah.
Okay. Let me ask you something. When you get hit with that arrow, do you break it off or do you pull it out? I've always wondered that.
We've already tested for speed. Now we've got to check for accuracy. So we're at the shooting range.
Dropping.
Compound bows are more accurate than traditional bows, and here's why. The cams are holding a lot of the draw weight, and since you're not holding back all that power and energy, you have plenty of time to aim this very powerful bow.
Now find your peep sight. There you go.
Finding my peep
Try to
sight.
get that string close to the tip of your nose.
I've been having trouble finding my peep sight for years. This is called the peep sight, and I'm aligning that with these pins.
And based on how far away the target is, you zero in on the right pin and fire.
Focus on your spot. Oh, ho, ho, ho.